Oh, hey everybody. Welcome. I'm Andrew. This is Code Gets Creative. We're back again, and Halloween is coming on. Hope everybody had a good Halloween. Trunk or treat was successful. My wife and I did a trunk or treat thing. It was really fun. We used the Philips Hue lights and the light blocks app from before, and the kids really loved it. So that was cool. Actually, there were a lot of kids that would come up to the trunk and they would look at all the fun decorations. We had potted plants and paper cutouts of mythical beasts and stuff. And they would look at those, and then they would look into the corners where the two Philips Hue lights were shining, and they were all sorts of crazy colors. And they would just stare at those lights until their parents would be like, okay, let's go to the next car, and drag them away. So that was pretty fun, seeing the kids get into it that much. But yeah, that was fun. Before I get into kind of the meat and potatoes of Screeps today, we're doing Screeps again. I have, I think, two things to talk about before that. Thing number one is this is complete. We did it. So this is the Universal Traveler, the MIDI controller, right, or MIDI translator. We got everything soldered in. The display actually works. I fixed a bug that had to do with the memory being blank. Basically, there's some flash memory on this chip that comes initialized as all 255s, all 1 forever. And so I needed to handle the case where it starts out as all ones. And so did that, and then everything works great. I'm able to control synths and all that cool stuff. And this is going to get installed in my friend Eric's studio tomorrow. So that should be really cool. It was going to happen last week, but he wasn't available. So we just bumped it a week, but it should be cool. Let me just set that carefully down so that doesn't crash and burn. Yeah, the other thing I wanted to mention is this. I think it'd be kind of cool to check this out. Oh, and it met its funding goal. Awesome. So this is kind of cool. What we're looking at here is called Open Control. It's a customizable control surface for Ableton Live. So you'll remember that last week we were making music. We were using Ableton Live, the software, to control all the synths. So this is a hardware project that controls Ableton, right? Very cool project. You can read all about it here. The creator, this is the boxed version of it, but you can see it does all these cool things. You can plug in all these foot pedals to control your software, or you can just use these buttons on kind of the DIY version. Read all about it. Let's see. Yeah, pocket version, boxed version, maker version. So this is kind of cool. If none of the models above suit you and you have the skills for it, you can always build your own enclosure. The maker version has all the features of its brothers and is up to you to imagine the best box for your own use. So yeah, this is kind of cool. I'm thinking about maybe backing this project because this could be useful for all kinds of cool stuff. Could help make music, could help even control lights potentially. Kind of cool. It's got this librarian software. It overlaps a lot with Universal Traveler, to be honest. It's not serving exactly the same need, but there's a little bit of overlap in terms of kind of the purpose. So that makes this interesting to me, both as a potential user of it, but also as maybe in the future I might do a Kickstarter project for the Universal Traveler. And so looking at a project like this and seeing how it does is inspiring, and it's also informative, right? Oh, that's cool. It's a 3D printed. Oh no, this one's made out of recycled plastic bottles. Kind of sweet. Yeah, so Thought some folks might be interested in this. All right, but now it is time for the main attraction. Time to get into Screeps. From the chat, we got Dollar Akshay. Yo, yo, yo. Good to have you with us. Zoss42. Hello. Thank you for joining as well. Yeah, good to have everybody with us. Thank you. So yeah, let's play some Screeps. Since the last Screeps... I've got all kinds of crazy changes. We'll figure this out in a minute. Oh, cool. Marvin's here, too. Welcome. Put down a construction site for your spawn. I'll build it. Oh, man. So, since the last stream... Let me see if I can multitask. Since the last stream, I got killed by some other player on Shard 3. And Dollar Akshay was there right next to me, saw a lot of it, and let me know. So thank you. I've been busy with work and stuff and haven't been able to actually get to it. So here we are, trying to respawn really quick, trying to get back in Shard 3. Dollar Akshay, just to be clear, it was not me. There are screenshots to prove who it actually was. That's funny. So, I think what we're going to do here is we're going to log into Shard 3. We're going to respawn where we were before. Yeah. Blah, blah, blah. So, I think... Don't forget to build defenses this time. Thank you. Appreciate it. So yeah, I guess it's the one that killed me? No, it wasn't. Okay, so the idea is we're just gonna pick one of these 3 rooms because we still have RCL in all of them. We've just got to place it, and then Dollar Akshay mercifully, thank you, will will build it for us. Dollar Akshay, do you have a preference for which room? Like, what's gonna be easiest for you? This one's probably the closest, right? Like, in terms of travel distance, because let's see, 1, 2, 3 versus 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5. Yeah. So, any room? Okay. Yeah, cool. Let's check out this one and see how it's doing. I mean, all of them have completely died, so it is what it is. Let's see. Yeah, let's grab this one. And eventually we're gonna fall back down until we can start rebuilding it. Okay, so our spawn goes here. Actually, you see this little S right here. Here's our room visual to tell us that this is where it would like us to be. So, kind of fun. You can still see kind of the dregs of the automatic expansion, even though we've died in this room. Okay. Spawn. Sure, spawn one. Okay, Dollar Akshay, it is official. So we're in, let me type this out, West 25, South 39. On it. Okay, you're the best. Thank you so much. Super, super, super appreciate this. Okay. We'll let that run its course. In the meantime, I'm going to jump back off of Shard 3. And I'm going to switch over to private server so that we can keep working on combat. And Dollar actually has a screenshot of whoever killed me. So maybe this is a grudge match. At the end of this series of combat videos, we will go track down the wandering soul that came and killed me, and we'll kill them back, and it'll be fun. But yeah, let's get started on that. You can check your history. Marvin says, name, I can get revenge if in range of me. Yay, combat. Room, oh, yeah, room history. Oh, yeah, should we, yeah, let's watch it together and relive my pain. That'll be fun. It looked like there was only a single creep that came in and just destroyed everything, so it was very high level, but apparently it was quite beefy, yeah. But it was just one, and I didn't do, like, I wasn't proactive enough with my bot to spawn enough defenses to defend. Let's see. So we'll just check out this one. Yeah, boosted creep. Thought so. Let's see. Replay room history. So we're good at this point. Okay. I don't think there are bad guys in here yet. Wait, what is this plus 10? Plus 100? Oh, there's a bunch of no data. Still good at this point. Thankfully you left your storage in your first room. Data. Still looking okay. Skipping around. Skipping around. Oh! Oh, there, okay. There they are. Okay. So you can see this gentleman heads in here. Nanaki? Apparently is the culprit here. Comes in here. Let's slow this down a little bit. Oh, there's a bunch of no data here. That is very inconvenient. Speed it up again. Yeah, look at that. At that point, I think there's a history in your first room. Okay, so maybe we'll have to go back to there. But, I mean, at this point, yeah, this guy's like trying his best to go attack. You can see that it's failing. This one is super, super boosted. So you can see catalyzed godium alkalide on all of these tough parts and these ranged attack parts and these heal parts. It's like super beefy. I'm also intrigued by this name because notice how it's like shard3 underscore something. Like this sounds like it's a really intense player that, like, I don't know, just like picks random rooms and then obliterates them. Very unfortunate. Yeah, let's click into this. GCL 10, so not super crazy. Expansion rank 130, that's very good. I'm going to guess that all of these are level 8s. Yeah, just boom. Rose through the ranks. Should we check out one of these? Walls usually help to buy some time to spawn defenders. Yeah, that's a great point. Oh, look at the cool decorations. I like that. Here they are. Lots of cool stuff saved up. Factory. There's a terminal. Lots of stuff in the terminal. So definitely like very, very late game. And yeah. But against boosted, I think can't kill without having boost yourself. I'm kind of suspicious of that. Like I would just need so much firepower to keep up. Like that creep was also like very boosted on healing, and so it looks like it was well equipped to like fire, but then heal itself, fire, heal, kind of a thing. Maybe only if it is just one, and you have 6 towers at RCL 8 plus some defenders. Yeah, like I think that's probably possible. Yeah, like if I had just been kind of smarter about like have some walls, have some ramparts, be able to like hold down fire for an extended period of time. Yeah, if damage too much or heal a tower. Yeah, totally. Like yeah, so I think there's a bunch of stuff we can do. So really great points. Okay, so yeah, if anybody wants to go attack this very intense player, feel free. I don't think I'm ready to just yet, but yeah, if y'all are cool with that, I'm gonna go ahead and switch back to the private server, and we can start working on some of our combat stuff. Because the best defense is good offense. So here I go. Get back into it. Do private server. Start the server. While I'm working on this, does everybody know what Kubernetes is by chance? I'm very curious. The other day, my website went down, and my website happens to be running on Kubernetes. And so, without too much trouble, I was able to get everything back working again. But since everything's running on Kubernetes, now that kind of the basics are in place, the foundational stuff, not the basics, it was really painful and hard to get the foundational stuff set up. But now that kind of the core stuff in Kubernetes are set up for my website, it's really pretty easy to incrementally add one more thing to my website. And so one of these days, maybe we'll do a session on like, here's how you set up a dedicated game server for Screeps or for something else on Kubernetes. I'd be very interested, like if y'all have experience with it, or if that would be something that you're curious about, like how do you run a dedicated game server? Could be cool, could be fun. Okay, so that is running. I have to close the ad. I have to. Let's see, I should also minimize this. Okay, here's our Screeps spot. Here's the source for it. We want to make sure that we're outputting our bundle to the right place. There we go. Okay, cool. So that's doing its thing. Oh, okay. I wanna brag about one more thing. Let's see. I think it is beneficial. I think Kubernetes is beneficial if you have multiple servers or something like distributed system or microservices. Yeah. The reason it is, well, I wanted to focus on it because we use it at work, and I'm not usually one of the people that like operates Kubernetes. We have a whole team to like really focus on that, but I needed to know enough about it that I could kind of help with that. So I was like, oh, cool, I could set up my home website to run in Kubernetes too. But my home website does actually have 6 or 7 subdomains that are all running like totally different things. So I actually think it's justified for my little website at home. Like I'm able to get some pretty good mileage out of Kubernetes at home. Kind of cool. There's one more thing I want to brag about, and I think you all might be interested in this. Let's see, where do I have this set up exactly? We're going to talk about visualizing static analysis. So let's see, where's my harasser role? So you remember we worked on this in Combat Part 1. You can go back and watch the video on YouTube. Remember that we basically have a creep whose job it is to rally, right? Kind of meet up with a big group and then go into harass a room and just like stand there, right? Until it gets beat up a bunch and then it retreats back to rallying, right? And so it's able to do all that. We talked about all that. This is starting to get a little long, right? Like the state machine starts on 53, ends on 155. So it's about 100 lines worth of state machine logic. And I mean, each of the states is its own little mini function. So it isn't crazy. The thing is, I would love to be able to see like a diagram of the states and the state changes. So if we head over to here, you'll remember, yeah, this is our state machine for the harasser role, right? So we start on waiting, move through all this stuff. This is all really cool. We were able to visualize it. What about when we change this? We now have to keep this diagram in sync with the code, or else we're going to get super confused. You know what I mean? And so what if there was a way that we could actually generate this automatically based on what the code says? Well, it turns out you can, and that process is through static code analysis. So check this out. I wrote a little bit of code here that will read. Oh, let's see. This is on the friendly fire tester. Let's do this on harasser. Switch this over really quick. And what this is going to do is it's going to read my source code. Here, I'll put this over here. So it's actually going to read the source code, and it's going to parse an AST. AST is short for abstract syntax tree, and this is basically a data structure that JavaScript uses in order to understand what my code is doing. So it'll parse that, and it'll look for a bunch of patterns in it, and then it'll actually output some other text. And this is in a language called GraphViz. And GraphViz is a way that you can create diagrams using source code. So if I run this bad boy, if I go into Tools, npm start, then it'll think for a minute. Oh, what? Hold on. I think I just ran the wrong thing. Tools. Oh, there's no tools. Okay. Node analyze.js. So if I run this, notice how it grabs a bunch of info out of here. So it's like, oh, the initial state is waiting. And you can see that here. So it was able to find that. And then the state transitions are waiting can transition to moving to rally. You see how waiting, as it ticks, it's either going to return null, meaning it'll stay in the same state, or it will return moving to rally. So it figured out that transition. Moving to rally can either go to waiting or rallying. So here's waiting and here's rallying, and etc. for all of these. So it was able to figure all of this stuff out. So then it was able to generate this GraphViz source code. And so if you've never read GraphViz before, it's not too bad. Basically, this is a node. This node is called start, and it's described a little bit. It's invisible, or it's there's no box drawn around it. And then the edges have these little arrows. So start goes to waiting, waiting goes to this, moving rally goes to these things, right? And then we can run another program to actually take this and turn it into an image. And that code is really pretty simple. Yeah, here it is. And so it basically says like, read that graphviz file, right? Cat it out, and then take the result of that and run it through a program called dot. And dot is one of the sub-programs of graphviz. And it basically says like, yeah, take that graph source code and create a PNG, and this should be the name of it. And so now for the big reveal, it created this file. It created this image. So there we go. So this is pretty cool. What this basically means is that I can run one or two commands, and whatever, where did this harasser go? Whatever happens to be in the source code becomes this picture. And so I can automatically document exactly how my code works, but at a more zoomed out level, right? So pretty cool. So far I have to kind of manually change this stuff to say like, hey, only do, like only run it on harasser, but you can imagine this being done like in a loop, where it could like read out every single file that's in the in this roles directory and just say like, every single one of these, go ahead and extract the state machine and then turn it into this. Yeah, Icarus HQ, first time chat, cool, welcome, good to have you with us. Can you do it on build? Yes, yeah, you definitely could. So let's see, this repo is on GitHub, and GitHub has this feature called GitHub Actions, which lets you do continuous integration. And so, oh, well, I guess on build can mean two different things. So you'll notice I run npm start, and that runs webpack. But yeah, like Icarus, to your point, like this same command could also totally run all that analysis. So it could be like, okay, bundle it all up, also generate the docs, generate the images, so that, and then hot reload. So like every time I change the source, it auto updates those PNGs. And so I have like continually updating documentation around whatever the state of my bot is. Pretty cool, pretty powerful. Okay, so I'm going back through the chat. DOS42 is talking about attacking. Yeah, my previous codebase for attacking groups is used multiple rooms to spawn and send them to closest room. They go for a raid. And then while not all of them spawned, arrived, they used renew. Oh yeah, cool. So you keep them all going. So when last creep arrives, they're all equal TTL, almost full. Yeah, I like that. That's cool. So you're able to build up this like really big army, and you know that they're all going to live long enough, and then you can like blast into a room all at once with everybody. That's really cool. Yeah, I think we need to be thinking about that same type of thing here. So very cool. All right. Let's check this out. Actually, so I want to go check on this room, and the reason for that is because it will actually help us to test with MichaelBot. Shout out to MichaelBot. MichaelBot is going to be our first victim as we try this out. From the previous time, what we actually did is we just used these two rooms right here. So we rallied in the left room, and then we attacked into the right room, and we made friendly fire testers where they would attack my own harassers to see how they would behave. So that's pretty cool. one of the things that I've learned, and I did this in between streams, I wanted to figure out, like, how does a single harasser hold up if you've got like 3 towers, or even if you've got 6 towers? And it turns out that it's really bad. It gets totally obliterated, at least at the smaller RCLs where you can't get as much body parts put together. It's really bad. It gets blown up in just a few ticks. And so I think I had all of these like cool ideas for, like, we're gonna get into formation and a checkerboard pattern once we get into the bad room or the enemy room. I think that might be the wrong kind of optimization for really heavily defended rooms. I think what we should do instead is, let me click into this and I'll show you. I think what I'll do, so this is the rallying room, right? Notice how this is the surface area where I can attack or harass. So any of these squares is like a candidate for moving into a room. And so I think maybe what I should do is set this up so that I can set up a whole wave, and the wave will just like line up here. And then when everybody's ready to go all at once, then they'll all step into the room at the same tick, and then we'll go from there. I think that should be cool. Zaz says, have you checked my message about Screeps notifications I made? I managed to send them from Screeps code to my Discord. Oh, super cool. Yeah, that's awesome. Yeah, that's really cool. Very handy. Like, I found that the default, when Screeps just like sends an email, like they all get bunched up. I miss them. I don't do anything with them. So yeah, I like that. Cool. Okay, yeah, let's set up for this then. We're gonna need some harassers, and then we're gonna need to start changing some of this stuff. So we need a rally. Let's see, one-off scripting for harassing. So yeah, we need to rally into this room, which is West 8 North 2. West 8 North 2. And let's just rally around like here. 4315. 4315. And then we need to queue up a bunch of harassers. There's still not a good way to do this. I want to be able to say like game.rooms and then whatever this room is, West 8 3, West 8 North 3, and I want to be able to say queue harasser, and I should be able to just run this and it'll like add it to that spawn queue that we've done earlier. So let's do that really quick. So let's see, we need to do room.prototype. Yeah, here we go. So we'll add it right here. Prototype.queue. And this is going to complain because we need to add it to here. And let's see, this is going to take a role name, which is a string, and that returns a void. Okay, so now I can come back over to here. This is happy. And I should be able to say this .memory.spawnQ.push. Notice we're using TypeScript here, so it is complaining in all of the helpful places, so it's telling us what it should be. Homeroom should be this .name. Target room should be this .name. Role should be role name. Role name. Yeah. Okay, so now this should be a thing. So if we add this, then in the next 10 ticks, it should pick it up. Spawn new harasser. Good, it's doing its thing. And we need to tell the army what to do. We'll do that. And let's see, we should get this room to help. That would be cool. West 7 North 4. West 7 North 4. And let's we'll queue up a couple in each room, yeah? So we got 4 harassers all on the way. Cool. Yeah, Zos is describing the Discord integration. There's a web server, uses memory segments and Screeps, and then uses a MySQL database. Yeah, cool. Because I guess you've got to keep track of have I sent this particular notification yet or not. Yeah, that's awesome. Good work. All right, we're coming back over to this first room. I think that was our harasser that just went in there. So let's run over to here. Is this our friend? Yes, it is. Okay. Good, good. They're doing that. So let's see. One of the interesting problems that we will run into here is that there's only one square here, you know what I mean? As soon as I guess you can walk along this edge, right? If I remember correctly, you can stand here and move down, and you won't or am I remembering wrong? I think you can do that. I guess we could just put it into harassing mode. That would totally work. Here we go. Now they've both decided to harass. Moves. I should know this off the top of my head. Yeah, okay, it's as soon as it steps on the arrows, it goes. Here goes the other one. And boom. So what that means in terms of spacing is that I only have one grid cell to work with, or else I need to go all the way around. What I don't want to do is if there's a creep that's blocking this direction, I don't want one of them to accidentally go into the other room and then come back, because you can see how that would be a problem. Yeah, but here's all of our harassers all gathered up. That's cool. All right. We've got them all in there. Let's bring them back, right? And I think let's let's consult this. Is there a way to move back to rallying? There's not. Haha! So this has already helped us. I need a way for these guys to go back to where they were before. So right now they're harassing standing ground. I need them to move back to rallying. So, and let's close all this random stuff. Am I changing the worker? I don't think that was from before. Let's see. Harassing standing ground. So right here, we can get the context of the creep. Oh no. We don't need the creep's context. We need the army's context. So right here, we'll say if order.type is rally. Then we're going to return, what is it? Moving to rally? Yeah. Okay, so update that. And by the way, this is my chance to say tools, no, node, tools/analyze, and generate. There. We chain those together. There we go. You'll notice that it's shifted around a little bit, but that's just fine. Yeah, it looks great. Cool. So at this point, yeah, they've already left. And they should have gone back to here. Okay, and I guess they're a set amount of distance from the center point there. So that's cool. All right. So let's maybe look at our army. I think, let's see, we've got to harass. The thing that I'm thinking about right now is basically, like, there's a state machine for the army, and the creep state machines should respect the army's state machine. So I want to be able to say something like, let's see, I'll pseudocode this out a little bit, but we want to be able to say like harass room X, and within that, it might be rally, like gather a big army, get into position, and then send the gather, maybe like gather a wave, get into position, and then send the wave. And then I think once we have sent the wave, it should be gather a wave, heal, prepare to go in again. And really, like, I think we can collapse this state in with this state. Maybe there's also like create a bunch of creeps, and then maybe like gather. Yeah, it's like rally, heal, prepare to go in, and then send the wave. That happens, and then this one right here, gather wave, heal, prepare. Really, it's this: rally, heal, prepare to go in. So notice how it repeats. Yeah, will army be also a state machine? Yes, I think so. which, by the way, I've state machine here. Yeah, right now it's called run creep state machine. Yeah, and it runs on a creep. So I think I probably need to change this a little bit so it's more generic. Because I would love for this to, like, I would love to just be able to reuse state machines for anything. That would be super cool. So Army can request spawning creeps. Yeah, I think so. And I think it may not stay in this for very long. Like maybe what it'll do is it'll say, okay, I'm in that first state. I'm gonna send out a bunch of requests, and then I will. Oh hey. And then I'll immediately go to the next state and cycle. It seems similar to operation or mission then. Yeah, that's a great point. Like if you want to attack or harass, you will create an instance of that army, and for times when you don't want it to have no armies. Yeah, I think I see what you mean. It's basically like we might have several of these. Maybe multiple armies also. Yeah, not today. Like at this point, my code only has the concept of one army. And I think that's okay for now. There are a lot of other improvements I'll need to make before I can really like realistically support multiple armies. So I'm cool with keeping it this way for now. I do really like your point about missions or like operations. Because then I can treat that as the state machine. The army basically holds the current operation. And that, yeah, yeah. There's a ton of stuff I like about that. Great call. Let's start planning this. Okay. So let's organize this a little bit. Let's pick a name for this. Yeah, let's operation mission. I guess they're kind of synonyms. They're pretty direct synonyms. I like mission because mission is maybe more military than, I don't know, they both are. Mission takes an army as a parameter in order that army to do stuff. Yeah, you could flip it either way. So you could say an army composes a mission, or a mission composes an army. I think I'm probably going to do it the other way. So the army composes the mission. Okay, so what are our states? I think we have planning. Oh, and we probably got mission harass a room. Or harass room. It's maybe not even harass room. It's probably like destroy. It's like conquer a room. Conquer room, destroy room, attack room. Let's see that. So planning. Yeah, well, let's see. So this is like figure out where, figure out placement, request waves, or request creeps to be spawned. And we are going to have a problem here where creeps will die and we'll need to re-request them. And so maybe this V1 isn't going to handle that, but we'll be able to get to that. Term harass I usually use for stealing remote miners' resources from containers when they're not protected. That's a good point. Yeah, like harass is maybe a little overloaded. Destroying roads and containers. Yeah, sweet. So actually, this should probably be like attack homeroom. The point being that like we're focused on an enemy's homeroom rather than their outpost room or their remote room. Okay. We got planning. We've got, and I think we just kind of made it, right? So I think this is, should we call this rallying? Rallying. And then we've got, let's move this over here. Harassing, for now it's called harassing, right? Maybe it's like assaulting. Basically, there's going to be like a frontal assault where we actually send in like attacker creeps that will actually do damage, dismantle, like all that good stuff. Let's see, rally, heal, yeah. Creeps should rally. Creeps should heal. And then creeps should line up at the room exit. Let's see, for own rooms, it might be kill creep, spawn, destroy structures, mostly towers and spawns. Free path to a controller and attack it so it'll downgrade faster. Yes, great point. Downgrade controller. Yeah, maybe it's like, I think there's probably like a main attacking phase where it's like just destroy everything you can, and then eventually you finish that state where you're like, okay, all the dangerous stuff is over. I've destroyed their spawn, their towers, whatever, like they can't come back. Then it's sort of like post-attack. And post-attack is like attack the controller to downgrade faster. And then it's like raid the storage, dismantle other stuff. Probably in this order. Different types of creep will you already. It can be like multiple types of states then. Yeah, essentially. Maybe it's more like it's a hierarchical state machine or an HSM. So the army's state machine is really big, and then there are multiple creep roles that care about each of these states. So if we're in post-attack, then if you're a harasser creep, you should be dismantling buildings. But if it's post-attack and you're a claimer, you should be attacking the controller. That kind of stuff. Yeah. Okay. And this is like directly attacking towers. Probably, yeah, towers, walls, ramparts, spawns. In no particular order. Cool. Zaz is talking about how like different types of attackers are better for different situations, like maybe dismantlers, maybe ranged attacks for ramparts. Yeah, good point. So yeah, we'll have to figure all this stuff out for sure. And then creeps should. So for harassing, creeps. So okay, let's. I'm gonna change the name maybe. I'm gonna call it like sieging. I guess it's besieging is the correct way to say that. So creeps should stand at the exit in the enemy room. And then creeps should retreat when HP is lower. Okay. So I think we got all that. So let's write some types. This is like my favorite thing. Y'all know this is my favorite thing. Army order. You'll notice, actually, I think army order is not even being... No, army order is being used. That's how we're doing this stuff. So let's change this. And then we're removing these, essentially. So now I guess we want this... Oh, you know what? This is a little... Okay. I think we want something a little different here. I think we really want to say Army Mission. So if the Army has no mission, it's typed as none. Attack, home, room, and then room name is a string. And I don't think I actually want to put this at the very... Well... Yeah, we could try it. Attack home room state. And so this state, this is where we're going to reference all this stuff. And let's do some copy pasta. So we've got planning, rallying, besieging, attacking, post-attack. Okay, so we've got these states. The reason I've chosen to do this independently of this is that I think we want to have it so that the army order is more immediate. So the army knows how to deal with all this cool stuff. It's like, oh yeah, we're attacking a homeroom, and most immediately we are besieging. That's like the state that we're in. But each individual creep role probably shouldn't know about that. So I probably don't want the harasser role to know, like, oh yeah, we're in the besieging state. Like, it should probably just know, like, oh, my job right now is to harass. Okay, got it, I'll go harass. And so now what that means is we could go add a whole bunch of other army missions, but as long as we keep army orders really simple, those creeps can keep doing their job. So notice how this is in actual armed forces terms, this is like a need to know basis. Basically, we're saying our combat creeps only know this stuff. Oh, and get rid of this. Oh wait, what was this before? There. Our creeps only know this like tactical stuff, but this higher level strategic stuff is decided by the army, right? So this is separation of concerns. That's kind of the architectural benefit that we're getting from this. Okay. So let's do this. We need to save this. Like, let's see, we have an order, and then we need a mission. Let's see. I think all types of missions will have one target room. Probably. I imagine that there could be other sorts of, like... There might be other interesting ones, like, oh, this army's mission is defend this supply route. And so the target rooms are actually like a list full of rooms. So it's like, I don't know, I need to go all the way from here to here to here to here. You know, there's like 4 rooms, and I need to defend all of them. And so the army will like load balance itself so that there's one defender in every room. And since we're using union types here, like we could potentially do that, right? It could be like defend, supply, route, and then it could be like rooms is a string array, something like that. So pretty cool. This architecture allows for that kind of addition in the future. Okay, so let's build this. There will also be one that's like, also, I'm going to call this enemy homeroom, because eventually I want to have defend my homeroom. Like that would have really come in handy when that enemy came in and was like a super boosted creep. Like if I had had a mission that was like, you know, gather up a big wave from all 3 of my rooms and charge all of them in to defend the same room at the same time, I might have stood a chance, you know what I mean? Because if I could supply from all the rooms, I could send lots and lots of moderately powered creeps, and maybe I could have survived. So defend homeroom is, or like defend my homeroom is a future thing we could do. Okay, so we did that. Where do we actually initialize the empire? I think that's in here. Yes. Okay, so now we initialize that. Yep, defend homeroom is obvious type of thing. Yeah, and notice how like defend homeroom is different from type none, because like in peacetime, I probably don't need to do that, right? Like it probably is not worth the resources to like pump creeps into a room. It's just not, it's wasteful, right? But as soon as I start getting attacked and somebody's like banging down my front door, then boom, I switch into that mission and I'm able to defend myself, and it makes sense to spend all that extra money. Okay. Maybe I should call this like get tactic. Maybe that's a better, well, no, order is fine. You know, what are your marching orders kind of thing? Okay, so we've got that. Let me just double check that my code is building. Yeah. Oh, I think all my harassers have died by now. They've all timed out. Cool. Let's see. We need a system that's like run the army. So here's run empire. So I think right here it should be like run army. So we initialize some stuff. Let's see. How do we call get army? Get army. We have our army. And then this Zaz says, I have a good system for detecting attacks that need to be reacted, but I have no reaction code yet, except for spawning bigger workers or brain walls. That's fair. I mean, it's two pieces, right? Like you have to detect it and then you have to react. So yeah, it's a really important first step. Okay, so we have our army, and now let's see, we've got army. Maybe right here we can say mission dot attack room dot ts. No, what did I actually call it? Where's all my code? Attack enemy homeroom. Let's name it the same thing. Attack enemy homeroom. Okay. And then let me close the harasser for a sec. Let's grab, yeah, I think I want to move all this. So grab this, and I'm going to move it into here. So all of the army types live right next to the army. Save that. Let's see, so that does break a bunch of stuff. There are roles that are listening for that. Oh, this wasn't even looking for that. Okay, that's good. Up here, we'll get rid of this, and then let that autocomplete. So there's that. Cool. That's talking about that implementation. Very nice. Let's see. So are we building yet? No, looks like we gotta. There are two roles to look for that. One of which is a harasser. Wait, do I even? Oh, I didn't even use it apparently. Okay, so that's good. And then attacker is in here. If I remove that, oh look, I forgot I did this last session, but yeah, I just straight up commented out this role that I wasn't ready to work with yet. So that's kind of great. We'll get to it. We're obviously not ready yet. Like, we don't even need that role until we get through all of this and we're here. So we'll build that in like session 3 or 4. Okay, so I think my code. Oh, is attacker? Wait, no, I changed that. Let's just reload this. Double check it's all working. Come on. There we go. Okay, so build is green. We're back working again. I'm gonna close that. That's my background music. Okay. So let's see. We need a way to run the mission, right? So here's run army. And really, I want to be able to just say like run. Or like run mission, something like that. Go that here. I'm gonna define it here. Run mission. Let's see. So now we gotta say mission is memory.empire.army.mission. Now note that right now this is a singleton. Right, you can tell it's a singleton up here. Eventually we'll get really fancy, and we'll have multiple armies. In the meantime, this should work just great. Marvin says, thanks for turning me on to TypeScript. Hey, happy to do that. Glad you were enjoying it. It's like, at a certain point, our code gets big enough that it really, really makes sense for TypeScript or that, like similar things. So that's awesome. Okay, so we've got our mission, and now I think we need a concept of like a mission runner, which is basically like it's the polymorphism that says, depending on whatever this is, like here's how you actually implement it. So we'll have to export that, and we'll say army mission runner. Oh, and this can be an interface. So this interface, it's probably like get name. I don't know if we need get name. Let's see if we can just do like mission. So mission is of type army mission. And then it returns void. That might be it. Then we probably need mission runners. And this is going to be a big object. And this will be like, let's see, it's actually, we'll nest this a little deeper to make it clear. So then this will feel really silly, but we will need to have none. So let's say mission none runner, and this is of type mission runner, and I want single quotes. Kind of silly that way, however. And now we need the run method. And we can write it this way. And this one is really easy to implement. You say return, do nothing at all. Okay, so you've got that, and then there's some boilerplate here. Enemy home room runner. Save that, and then we need to register both of them. And then right here, so we have them all registered. And now right here, we should be able to say the runner is mission runners at index mission.type, and then if there's no runner, then we should throw a new type error, and then we'll say mission type mission.type has no runner defined. Cool. But then at that point, we should be able to say runner.run. And then we pass in the mission. Okay. So I like that. Now, there's something that we could do. we're going to do generics here. Check this out. This is going to get real cool. So mission is going to be of type M. And what I'm going to do is I'm actually going to say, what I'm doing here is I'm locking down the types even more so that it'll be easier, like we'll have more guarantees inside of here. So, Dollar Akshay, oh no, generics, I dread them. So don't worry, we're going to do this part together. We got this. So what I'm going to do is I'm going to say, let's see, export type mission none. And this is going to be type none. Oh no, sorry, type none as a string literal. Okay. And now what we're going to do is this is a mission runner of type mission none. And so now when I hover over this, it's not just any type of mission. I know that it's this specific subtype. And I can put that, whoops, sorry, I'm skipping around, pressing the wrong keys. Now what I can do is I can put it here into my union type, and like everybody else still sees it the same way, but there's more protection in here, in the actual runner. So now we're going to do the same thing with attack enemy homeroom. We're going to say, copy a bit of boilerplate. Move that into here. Move that into here. This is a little long, so we'll actually format it differently. And now we can say attack enemy homeroom. That's our mission. So now we use that in the generics. And then we can do that here. Sweet. So that all looks good. Okay. Now, let's see. We need a way... Yeah, we've got a conflict in here. That makes sense. What is the most correct way to... We need type guards here. We need runtime checks. By the way, Dollar actually, did this make sense? Like how we're using this generic here. It gets, it's a variable here, essentially. The type is a variable. And then we're able to reference it here. So yeah, if you got more questions about that, let me know. That would be awesome. We can talk more about it. So what is the safest way to do here? We need a way to cast it. No, I don't want to do that. I guess one thing that we could do is say like runner is maybe like validate mission. Then what we can basically do is create a type guard inside of each of these. Ooh, we'll see if that works. I don't know if it will. Okay, cool. Let's give this a try. Validate mission, and this is going to say mission is a generic mission, army mission, and it is going to return mission is M. Can I do this? Let's see, I understand simple generics, but man, it really gets complicated sometimes. Yeah, I respect that. Now that I've written this, and this is complaining, this may be one of those times. We're just about to find out. Mission is M. So why can I not do this? Type M is not assignable to mission, and that's because it can be that. Is that actually just because the runner isn't implemented yet? Validate mission. So here's our army mission. And then I'm just going to say if, or no, I'll return mission dot type is attack enemy home. So let's see, it says this is not. Oh, so maybe I have to write this a little differently. Mission is this. Okay, so it likes that. That compiles. Is M, what does it do? So yeah, so this is weird to think about. M is a variable, and the data type of M is type. So let's take another example. Notice how like here's a variable, you know, it's called flags. The type of this variable is flag array. So there's an array, there's a bunch of flag objects inside of it. That's the type of flags. So then up here, M, this capital M, it's also a variable. You know that it's a variable because of this. So this syntax gives that away. When you've got triangle bracket M, well, triangle bracket, single letter, triangle bracket, used like right here next to the interface name. So, okay, and we can look this up in the TypeScript docs, like, this is the grammar for defining generics. So, okay, cool, there's this type, or there's this variable of type. So in other words, M could be anything, right? So what we're doing here is we're saying, if you are an army mission runner, which like, here's one, for example, then we're saying run a mission, right? Well, what is the type of mission? Well, actually the type of mission is that variable. So whatever we say this outer type is, whatever we say this object is, then the input for this is going to be that same type. So in other words, mission needs to be of type mission attack enemy homeroom. Let's see. But M is just a TypeScript name. Mission is M, cannot be checked at runtime, am I right? So, many things can't be checked in runtime with TS. So, so here's the thing. It's actually the reverse. So many things can't be checked at build time with TypeScript. So this is called a type predicate, which basically means this function is going to return a Boolean, and you can see that happening here. So we know that the return type here is going to be either true or false. But this gives us a little bit of extra knowledge. So it says mission is M, whatever M may be. And so you might use this if you're doing something unsafe. Maybe an example of this is you're reading from shared, what are they called? Memory segments. So shared memory segments, Actually, let's pseudocode this out. So let's say like memory segment data is, you know, get memory segment 5, whatever this is, right? So bear with me, I can't remember how to do that. But this type, we can't guarantee it. So let's say that we want to have a type that's like, ally chat message, or maybe it's like ally request. Okay, there's some type called ally request, and whatever, you can imagine there's some stuff in here. And so we really want memory segment 5. We want memory segment 5 to be an ally request, but we don't know if it actually is. Like, our ally might have actually formatted it incorrectly. And the same is true for any sort of software where like we're making like an API request to some other like system. Like maybe they're returning what we expect and maybe they're not. And so we can do a little bit of defensive programming. So the way we would do this is we would say the result of this function is unknown. It could be anything at all. And then what we would do is we would have a function is ally request memory segment data, right? And its type is unknown. And then we would say memory segment data is ally request. Return false for now. So you can see how like it's going to be that. Let's maybe make up some stuff here. So maybe this would be like type request energy, and then there's like an amount, and maybe there's another one that's like request defense help string, right? And so there's like kind of some different options here. So what we might do is say if memory segment data, if it's an object, well, we'd probably say like if it's not an object, or memory segment data is null, because it turns out type of null equals object, which is crazy pains. So then right here, we might say if memory segment data has own property type, or maybe we'd say if it doesn't have type, we're going to return false. You see how we're basically like chiseling away all the options here. And you know, so maybe just like do other checks here, and then eventually if it's like, you know what, I couldn't come up with anything else, like looks like you got everything I was expecting, like you either look like this or you look like this, and like cool. But notice like the important thing here is that like it's impossible to do this check at build time, because this is going to go reach out to some data that exists in some other system. Like I don't have control over it, so I don't have that guarantee. And so I type it as unknown, and then I use this runtime type check. And so this helps me go from, you know, the world of like risky untyped stuff to the safer world of like, I know what this is, I can promise that like it's gonna look a certain way. So that's what this is for. Cool. Yeah, again, that's called type guards. So type guards use predicates in order to check that stuff, and it checks it at runtime. Okay. Oh, and let's see, ZOS42. Yeah, you made a point. It's not like where in C# for generics. So I believe if where works sort of similar to Elixir, Elixir has a keyword when. The difference is preconditions versus postconditions. it's basically like the where keyword is saying the input, like I know that the input is some certain thing, and it runs before my function starts. Whereas these type guards is making an assertion that happens at the very end of the function. So it's like I ran all this code and I decided this is either true or false. And so then based on this true or false, that's going to tell me that this variable is of type this. So there you go. Only if you make the validations code correct. Yes, that is absolutely true. That is one of the limitations of TypeScript. So TypeScript, well, and as a matter of fact, yeah, there are other ways where like other languages struggle with this. The specific way that TypeScript struggles with this is that TypeScript is what's called a gradually typed language. So it's possible to have some TypeScript code interact with some JavaScript code. An unknown is like, this is dynamically typed. Whatever it is, like it's dynamic, I don't know what it is. In other languages that are strictly typed, it's impossible to have that. You can't have an unknown type. What you have instead is like, you might have a string of JSON, or you might have a byte stream of like ones and zeros that represent audio or whatever. But it like absolutely everything has a concrete type. Whereas if we go back to here, like TypeScript, since it's gradually typed, it has this concept of unknown. That's that. Okay. Cool. So all that aside, C# has object and dynamic. Oh, like the dynamic keyword. So let's see. This is where I actually don't know what the dynamic keyword does. I'm not a C# proficient person. Yeah, so I'd have to go look it up. It might be complementary to generics and polymorphism. But we'll need to cast it if you want to operate with it. Yeah, okay, that kind of makes sense. You have to know. So I think we're going to run into the same kind of thing. I think we are going to grow out of this. Because, well, let's see. M is not assignable to type mission attack enemy homeroom. Oh, so I need to be able to say, I think I can say extends army mission. Yes, that fixes it. Ha ha ha. This is why union types are cool. Okay, so let me explain what I just did. So with my code looking like this is not valid. As soon as I add this, TypeScript knows a little bit of extra, right? And so what it now understands is that like whatever M happens to be, M is always going to be the intersection of this. And the intersection of this, TypeScript is smart enough to figure out that every single one of these types has this field called type. And so, well, and really it doesn't even care that. It just says like, whatever these happen to look like, I know that M is going to extend from this. It's like good with that. And so given that, it can keep going. So now what we can do is, yeah, we can define this here, and then we can define this here. Now, let's see, to your point earlier, like those type guards are only as good as our implementation, so we could get those wrong. Now you can see how, like this isn't super safe, because like what if I forgot room name, and what if I forgot state, and what if state doesn't match one of these? Like this is not a very robust type guard. But since I have control over all the places where this is happening, I'm willing to write a type guard that's more lenient. Like, I'm okay with it. Now let's see. You can't, but TS is compiled to JS, so it is on JS side already. What will happen? Oh, you're talking about casting. Yeah. Like all of this assertion stuff is happening at build time. So when we do these type guards, like the type guard is changing control flow that happens at runtime, but we're writing code at build time that will adjust for those, right? So what we're just about to write over here let's see. Throw new type per mission type. No, I should probably say like mission runner is invalid. And then right here I'm going to JSON.stringify the mission. Else run this. Huh. Okay, I think we've got a problem here. Maybe this did not fix it. So the intersection mission none and mission attack enemy homeroom was reduced to never because property type has conflicting types. Oh, that's interesting. You can see how that's happening, right? Like, type is none, type is attack enemy homeroom. So as soon as we hit here, like, it could be that. Interesting. So I think this is a place where the TypeScript compiler just doesn't know better. Like, there's probably not a way to express this. And $Akshay, you're gonna laugh at me. I don't think we can do generics here. I could be wrong. Like, maybe there is a way to do it, but I think based on what we just saw, yeah, there's the XD. Thank you, thank you. GG, well played. Yeah, thanks. I think based on this, yeah, based on, oh, no, okay, well, so we can still use generics in a more limited way. Basically, we have to use generics with a typecast. So it's a little bit less safe, but we're willing to do it. Notice how, like, this inherently is kind of unsafe. Like, we're choosing to do a runtime type guard here, which is kind of unsafe. We might write it wrong. What we're gonna do instead is we're gonna say, let's see, I'm gonna delete this, and then delete this, and then I'm gonna break this apart. So I'm gonna say, switch mission.type. And then I'm going to say mission none runner dot run mission. Oh, whoops. I've been writing in other languages that don't have a lot of parens. Dot run mission. Oh. And then we'll move this up here. Oh, that's interesting. Yeah, we're not guaranteed to have a type here. So we will JSON stringify this. Aha, and then we can delete all of this. Okay, we didn't even need a typecast here. And this is because TypeScript in this case is really smart. So, all right, $Akshay, you got to take back your laugh. We got to keep the keep the generics, and we didn't even need a typecast. I feel super vindicated right now. Just kidding. But this is sweet. So yeah, I should actually rewrite this with my creep rolls probably. Because this is very safe. Like, it's not quite as like lookup mappy, so that's one downside, but like this is very safe code, which I like. So now notice how when none is really boring, I'm gonna just close it now. But when I come back to here, notice how this mission, we know it's of type mission attack enemy homeroom. We know it is, because this already did that validation that's defined here in the type system. So that's pretty sweet. The only downside is we'll need to add more case in that switch, but they're not very many mission types. Yeah. Could make dictionary access maybe. Well, so yeah, Zos, that's the thing. We tried to do it through a dictionary, and we couldn't express it safely through the type system. So the whole like M extends army mission, stuff like that, like TypeScript didn't understand when we tried to write it as a lookup dictionary. So I think we're forced to write it as a switch, but like the overhead of the switch is really minimal. So I think it's great. I'm not really concerned about it. Okay. So let's see. I'm gonna do some getters. I'm gonna just document some stuff here. And I'm gonna say trigger missions. And right here I'm gonna say mission none. And then we're going to say memory empire army dot mission equals type none. And then there's going to be another one that is mission attack enemy home room. And then we need a room name of type string. Memory empire army mission type. Ooh, you know what would be really cool here? I want an initialize right here. That would be great. So, let's see, I think I can close this. I can close this. Where's my army? Let's see. Okay, so here's run. Here's initialize. And this probably takes in a mission. Oh, what did I do here? We have an inversion of control problem here. So what I want to do, yeah, there's no way to set a default here. What I want to do is say something like, I want to like say some mission runner dot initialize. Right. I want to be able to say something like that. So it would be like, it'd be like the none mission runner dot initialize, and then right here the attack blah 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 mission runner dot initialize. Problem is, these are different shapes. Like their inputs are going to be different, because I can't really initialize this mission without knowing the room name. And the room name is specific to this mission type, which means that like the shape of this is different. Or really like it was this. I can't just pass this in. And so, yeah, I can't get clever with something like that, which probably means I can't have an initialize either. Maybe I still can, we'll see. But basically we'll have to do something like this, where we create the raw mission right here, inline. And then state should be type planning. Ooh, now one thing I could actually do initialize doesn't need to be part of this. It could just be, yeah. Okay, we're bringing initialize back. Room name is a string. And this is going to return a mission attacking room, blah, blah, blah. And then what I'm going to do is I'm going to move this into here. Why is it yelling? I need to be able to say, I need to say that it extends that. Can't do this. Object extends that. Kind of weird. Or actually, implements? No, I can't do that. I guess I could, not listed by interface. Yeah, so I forgot that this is more strict. So one thing that we could do is we could say initialize is of type any. So you have to have an initialize, but I have no idea what it looks like. Well, let's see. I probably need to lock it down a little more than that. Or is there? Let's see. Is there another way to express this? We could do an initializer type. That could be kind of, we'll try it. So this is of type I. So then this should be, I feel like that's too confusing. I'm already like, I don't know, I'm going too deep on this. If we write it as any, then I should be able to say mission attack enemy homeroom dot initialize with the room name. And it thinks it returns any, which I don't like. I can probably do something like this. Yeah, okay. Let's see, wait, is it the same type INAM? Yeah, what I was thinking is that type I would be of type function, and then I would get creative about like, it passes in, initialize becomes that type. So then I can specify up here, like within each of these missions, how it gets initialized, like the types for initializing it. Why does TS not like the code UST as simple as it is? Sorry, I'm not sure I understand. Yeah, there we go. We can just do args as any. As simple as it is. Like I don't understand what the current problem is. Yeah, let's see. So before, yeah, you didn't understand what the problem was at this point, probably, right? Like, so basically, this declares that initialize should be a function that returns m, right? And so the return type is great. Like this returns the same generic type, so that's perfect. But notice how the issue that this has is the type this is not assignable to the type this. Notice how the difference is the argument. So in other words, this isn't just a function, this is a function with 0 arguments, and that's the problem. So what we can do here, this is the spread operator where we're saying, hey, whatever the arguments happen to be, I don't care. I'm going to ignore all of that. Just promise me that you'll return type m. And then at that point, we're good. And we can override the args here. So that's what we're doing here. So that's sweet. And the cool thing about that is information hiding. So notice this like type planning. Like, I don't really want everybody else to know about the nitty-gritty details of the inner state machine of this. I just want to say, like, initialize yourself, however you happen to do that. And so, yeah, this allows me to do that now. So now I can rewrite this the same way. I can say mission none runner dot initialize, and there are no arguments. None. Wait, what is it? Just none.ts. Let's see, we'll steal some syntax out here. So we're going to pass no arguments. And this one is going to be very boring. It's just like that. Sweet. Okay, and now at this point I might tweak the syntax just a bit, just to make it a little more modern. And I think it knows, yeah, it knows this type. And then over here we can do the same. Yay. Okay, more minimal syntax, looks a little more approachable. So that's cool. Okay. Trigger immediate orders. Main runner. Okay, so we got some of that going on. Honestly, I don't even know if everybody else will need to get the mission. Maybe it should be hidden? I'm not sure. We'll find out. But I think this is a really good structure for now. I'm liking that. I'm gonna come back over to here. Oh, hey. Okay, so we broke our code, and we probably broke it for an extended period of time. My bad. This is a pretty easy fix, though. We just need to come over here to empire.army. And the problem is that there's no... Oh, how do I do this? Append? Yeah, and we need to say mission. Can I just start? That's gonna be a string, isn't it? Yeah, it is. I don't know what I'm doing. Okay, let's just say memory.empire.army.mission equals type none. Did that fix it? I think we're getting a new error now. Let's see. So run mission. Is it going to print out the mission? Man, it's being very grumpy. Tell me something that does exist. Oh man, we gotta have one of these moments in every session, right? Okay, so I don't see anything in there. Let's do this. We're gonna force this right into the main loop. Memory.empire.army.mission equals this. We're gonna force it to be fixed. There we go. Okay. Yay. We'll let these rooms kind of rebuild themselves right there in a pretty rough state. But they are back up and running. So now that that's doing its thing, we've got these runners working. We can prove that this is doing a thing by saying like no mission for the army to run, and we'll see this on every tick. Boom, 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 etc. So that's cool. So now we can implement this here. And so we've got a process that runs on every tick when it's time to attack an enemy homeroom. And we know it's going to be hitting this code. That's great. So we need to be looking at this state machine. Let's see. So I think there's just a big... Is there a big switch? I think probably I don't want to rewrite the whole creep state machine just yet, because that's going to be kind of nitty gritty work for right now. I think we've done quite a bit of cool stuff already for this session, so we might be kind of winding down. But let's see. If we do write this as a switch for now, it would be mission.state, really. Oh no, it's actually mission.state.type. That's right. And then it would be like planning. So like, here's what we do for planning. And like, run planning, something like that. Maybe pass in the mission. And we'll do that for a bunch of stuff. Planning, rallying, besieging, attacking, and then post-attack. Okay. And then we should... and this is exhaustive. So we're good. Okay, so then we need run planning, and we'll create a bunch of these. Run rallying, run besieging, run attacking. run post attack. Okay, and we've got, whoops, we got each of these. Put each of them there. Okay, so we're able to switch on those. How are these guys all doing? They're slowly catching up. Okay. So let's see, where is our logic? And we're gonna... Yeah, let's see. When we're harassing the room, really it's attack, enemy, homeroom. So create a bunch of creeps, and it's also like plan and. I think plan, like those are the same thing, really. So that's cool. So let's just start moving stuff. This is what happens here. Send the wave of harassers. And then this is frontal assault. And then this is... Didn't we write this somewhere else? I swear we did. Oh yeah, it's over here. Yeah. Let's we'll just pull this out of here and move it into the code. So move this here. Here's what rallying does. Here's what besieging does. Here's what attacking does. And here's what post-attack does. And somebody made the point earlier that we probably need a retreating state. So let's do that. Retreating. And this is not like, because there's going to be attacking, retreating on a more tactical basis, but this is like the entire mission has failed. Like we're giving up on the mission. Maybe eventually we'll have like a reporting system for like, you know, this mission is in progress. It started at tick number X, or like this mission has completed. It, you know, it started at tick X, it ended at tick Y, or it failed. That kind of thing. So we can build in a mechanism for that. And yeah, let's see. It's basically like run back to homerooms, and then future report the mission has failed. There we go. Sweet. Let's see, in simple case, can do like all in, and if it fails, just fight with creeps until death. Yeah, I like that. We don't get fancy with the state machine, we're just like Leroy Jenkins in automated form. Let's see, I use retreating as manual control logic by a flag. Oh, cool, so you're probably like retreat to here, right? Or maybe like retreat if you see this flag, like one or both of those. How is this thing doing? I really need to like kick this thing back into gear. Hue what do I even need? I don't know. Probably a worker. I should probably just let this thing do its thing. Like we won't really be able to test like the state machine too much, just because like the room has crashed in my folly. But I think yeah, can't control from console too. That is a great point, Zos. So that's really what these are for. I want to make it really easy to do that. So I can say creep.army. Is it .army? I think it is. Yeah. Creep.army.mission none. Right? And then eventually I can be like creep.army.mission attack enemy homeroom. Which actually, this is our chance to document. So maybe we'll say like creeps, rooms. I want to have a whole section for army. And it's, where did I just type that? Let's see, mission none. Maybe a long name type for, maybe a long name to type from console. Yeah, it's a little long. I mean, this does simplify it, and this is my cheat sheet. Like this is readme.md, right? So essentially I can just grab stuff off of here and it's really easy. Like it's easy to see how I use it. So I think that should be good. Can be just mission attack room or mission B attack. Yeah, maybe. For those that have, well, I don't know. I err on the side of longer variable and function names. That's just like who I am inside. I just like tend to have those longer names. So I don't mind, to be honest. Like I like the long name. I think it's like more clear what it's doing. So name. Mission attack enemy homeroom. Yeah, exactly. So you would call it like this. Set the current mission to none. Or maybe just like cancel any current mission. Attack an enemy player's homeroom. Attack a homeroom belonging to an enemy. Make it long and beautiful inside and short and handy from facade side. Yeah, that's fair. It's a facade essentially, so we can shorten it. I don't know. I'm pretty indifferent about like changing it. I want to keep going. So, all right, we've got this documented. This works. It does nothing. This works. It runs our state machine. So in here, there will be some state changes that we can run. And I think it'll basically be like, once we've figured out the placement, once we've requested the creeps, then like, boom, go straight into rallying. And we're gonna wait for, like rallying is gonna spend a little longer. It's gonna be like, okay, I expect X number of creeps to show up before I actually attack. Like there's a minimum of 8 or something like that, you know, pick some number. You gotta have 8, you gotta have a wave of 8 harassers in order to do this part of the mission. And so go ahead and do that. And like, we're not gonna move off of this state until we have that full wave. And then we also need to be able to say, like, let's say that we're in besieging mode, one of our creeps dies, then when we end up back in this state, we may need to request more. And that kind of sucks because this is where we're doing requesting. So honestly, we probably don't have enough. I think we actually want to move this into this state. So rallying now includes like whichever combat units already exist, rally them. If there are not enough, train them. That should be good. Okay, so I like that. Figure out placement is important, I think, because we need to be able to say stuff like, all right, we're attacking this room. Which room are you attacking from? And like, what are the coordinates that we're going to be rallying at? And we're going to have to like cache that somewhere. So that might be like rally position. Wait, where is iRoom position? That should be in somewhere. Oh, that won't autocomplete because I haven't defined it here. No, that's here. Sorry. Okay, rally position is iRoom position, and then I think that's it actually. Since we're going to change our algorithm a little bit. So let's see, spawning can take significant time. Existing creeps will time out if we lose much TTL. I think efficient to attack in waves. If the wave failed, then start to make a new one. Yeah, maybe. So maybe we say like, run the wave until it's just gone. Like, either it gets killed or it times out, and then make a full wave. Okay. Yeah, or we could... Yeah, remaining creeps could go on a suicide mission, fight to the death, or return home to renew or recycle. Yeah, I mean, eventually we could get really clever, like... I guess, like, a combat creep could probably... where am I going to write this? We need like availability for combat creeps, which is basically like doesn't exist yet, available, and then unavailable. Maybe it's like unavailable renewing. And Zos, that handles the situation you're talking about where like you might have a wave that gets really thin, and it probably makes sense to either like rush in and see what you can do, or else go and renew and maybe become part of the next wave. And so if we had a system to express like availability for these creeps, like, oh yeah, I'm ready to fight, I'm ready to do whatever, I can be part of a wave, then then that makes it a lot more possible to do renewing, to do like collapse one wave into the next wave so that we're not wasting. The reason that's so interesting is because I predict that we're going to spend a ton of time in these two states. Like if we're attacking a really high level player, we're going to be like besieging, rallying, just over and over for like hours at a time, maybe days at a time, who knows? Because it might be like, we've got to drain their towers, but meanwhile their towers are being replenished from their storage. And so we're doing this war of attrition where like we just have to like pump energy out of it. We just have to wait for it to drain, which is going to suck. So I think we're going to have to get clever so that we can sustain a really extended siege. Let's see. Renewing takes spawn time. I rather use it for aligning TTL for creeps that spawn at different time. Okay, that's a really good point. Because you can choose how much to renew, right? Recycling almost same energy return. Cool, yeah, okay. So yeah, I mean, maybe that's the way we should think about this, is like renewing is really to just like line up the availability for the army so everybody's available for the same duration. And then you say like this wave exists, it's going to do its thing, eventually it'll succeed or fail. If it fails, boom, we train another one. We go again. Okay, let's write that down. So each wave goes until it is. So I guess like we're getting rid of this, right? Like creep should retreat. We're not even going to do that. We're just going to say like each wave goes. Oh no, we could still do that. Actually, I take that back. Each wave goes until it succeeds or fails. Oh, Dollar Akshay, your spawn is now built. Bless your soul, my friend. That's amazing. Okay, sounds like I'm back in the game on Shard 3. Dollar Akshay, thank you so much. Let's see, for waiting other creeps spawning, I use renew if TTL drops below 80 or 90%. But don't renew last tick if it will overshoot TTL. Yep, that's a great point. You don't want to like spend for TTL that you won't actually use. Or like you don't want to pay for TTL that goes like overflowing. Cool. I've sent the construction bill on Discord. Oh, I will send you resources. I owe you one for sure. Oh, that's so good. Yeah, and I think I'll be able to bootstrap the other rooms from here too, because like it's at RCL 6. There's a spawn. I'll be able to get started again, and so I should be able to write a little bit of custom code to like send workers into the other rooms, build those spawns. Yeah, spawns are only 15k build effort. 15k. Well, so here's the thing, Marvin. Like, it's 15k energy. Also, by the way, the guy who attacked you wants that room. Oh, did they? They messaged you. Well, tell them no. Oh man, that probably means they'll come back. It's probably bad news. Maybe that means we need to push pause on attacking and really focus on defending, because they're sure to come back. Oh boy. Yeah, huh, that's intense. We've got a threat. Okay. Oh yeah, Marvin, I was gonna say, like, yeah, they're just 15k worth of build, but like it's 15k worth of build plus like the effort to like send out custom workers, build for an ally rather than for yourself, kind of like the goodwill, like social capital. Like that's not just 15k energy, it's a bunch more, you know, that's kind of intangible. So you gotta give Dollar Akshay that. Like give the man some credit. So okay, I think this is a really good place to leave off. Like we've got this awesome state machine set up. What is this? Oh, hey, we added rally position. Okay. Oh, but we don't know what the rally position is yet. Okay, we're gonna come back in and add that. So let's see. We'll go back in and like flesh out what the state machine actually does. Like we've got some pretty solid pseudocode. We need to go in and implement each of these states now. So I think that's going to be the next session. Unless I get killed before then, we will see. I billed him $1 million for that. Yay. We'll see how that goes. So, sweet. Yeah, and I think this will be a great place to leave off. Thank you, everybody. Hey, sorry to interrupt. Just place your spawns in other rooms. Yeah, I'll do that right after I jump off the stream. I'll log in and do that. Thank you for the reminder. So yeah, thank you everybody for tuning in. This was awesome. Appreciate everybody like jumping on and giving suggestions for like how to implement this. That was really cool. And yeah, let's see. We already talked about the hardware stuff, right? So yeah, remember for anybody that's joining, like this bad boy is going into the studio tomorrow, assuming all goes well. So I'll keep you all posted on that. I feel like there's one more thing. That open control thing was cool. In case people are interested in that, you can find it on Kickstarter. And yeah, thanks everybody. Again, I'm Andrew. This is Code Gets Creative. Talk to you later.